Now that you know how to name types 1 and 2 compounds, let us now learn about polyatomic ions. So far, what we have learned is that one element will have one charge. For example, in NaCl, sodium will have a charge of +1, chlorine will have a charge of -1. However, polyatomic ions are groups of elements that collectively carry just one charge. To make them very easy for you to understand, I am going to divide them into families. Let us start with one-membered families. Take a look at this polyatomic ion, OH, with a negative charge on it. Negative charge means -1. The negative is not only on hydrogen, but also on the oxygen. It is on both of them. This polyatomic ion is called hydroxide ion, and you just would have to know that name. Let us take a look at another example. CO3 with a charge of -2. Now, whether it is written as -2 or 2-, it is the same thing. This is called carbonate ion. Let us take a look at another one. NH4 with a charge of +1 on it. This is called ammonium ion. CN with a charge of -1. Again, remember the negative charge is on both of them. In polyatomic ions, the charges are not only on just one element. Cn- is cyanide ion. Let us take a look at another one. CrO4 with a charge of -2. This is called chromate ion. We also have Hco3 minus, which is called hydrogen carbonate ion. We have HSO3 with a charge of -1, which is called hydrogen sulfide ion. But these two also have very common names. Hydrogen carbonate ion is commonly called bicarbonate ion, while hydrogen sulfide ion is also commonly called bisulfide ion. Let us now proceed to two-membered families. For two-membered families, they look alike, just like family members usually look alike, but they have a very subtle difference. Take a look at this two-membered family. Can you see the similarity? They both have nitrogen in them, and they both have oxygen in them, and they carry the same charge, -1 in both cases. However, one of them has more oxygen than the other one. Let us take a look at another two-membered family. Again, they look alike. The same charge, they both have oxygen in them, and they both have sulfur in them. Just that one has more oxygen than the other. And let us take a look at another one. Can you again see the similarity? They are made up of the same element and they carry the same charge. The difference is just in the number of oxygen in them. There is a systematic way to name these two-membered polyatomic ions. And this is simply the trick to naming them. The member of the family that has more oxygen, we will end its name with ATE. The member of the family with fewer oxygen, we will end its name with ITE. It is that easy. So, for example, NO3 has more oxygen in it than NO2. So, the name of NO3 will be nitrate, ending with ATE because it is the member of the family that has more oxygen. Meanwhile, NO2 with fewer oxygen in it will be nitrite, which means it ends with ITE. In the same vein, SO3 is the member of the family with fewer oxygen, so its name will be sulfite, while the member of the family with more oxygen, SO4, its name will be sulfate. All of them have charges, so they all are ions. PO3 is the member of the family with fewer number of oxygen, so its name will be phosphite ion. PO4 is the one with more oxygen in it. Its name will be phosphate ion. Those are the two-membered families. Let us now move on to four-membered families. There are no three-membered families. For the four-membered families, let us take a look at an example. You can immediately see the similarity. They all have chlorine. They all have the same charge of -1. However, the number of oxygen in them vary. So how do we name four-membered families? We will still use the idea that the member with fewer oxygen should end with ITE, and the member with more oxygen should end in ATE. There is just one little problem. There are 4 of them. So using this idea is not going to solve the problem. The easiest way to remember how to deal with 4-membered families is to remember that if somebody has high blood pressure, that condition is called hypertension. And if somebody has too low blood pressure, that condition is called hypotension. Well, in this 4-membered family, the ClO with a charge of -1 on it has too little oxygen, which is analogous to having too low blood pressure. So we're going to prefix its name with hypo, and then we will still end the name with ITE. So we will call it hypochlorite. The hypo and the ITE are the 2 distinguishing features. On the other hand, the member of the family with a lot of oxygen, that has the most amount of oxygen, ClO3 minus, that is kind of like hypertension, but we do not prefix it with hyper. We simply prefix it with per, and we'll still make sure we end the name with ATE. So it will be perchlorate. The ATE is due to the fact that it has a lot of oxygen, more oxygen. And the per is due to the fact that it has a lot of oxygen. The remaining members of the family will simply be chloride, because it is the next with fewest number of oxygen, so it ends with ite. And chlorate, because it is the next in the most amount of oxygen, so it ends in 8. But again, remember, all of these are ions because they all carry charges. Let me give you some more 4-membered families. BrO minus, BrO2 minus, BrO3 minus, BrO4 minus. This one will simply be hypobromite ion, hypo and the ITE, while this one will be bromite, this will be bromate, while this will be perbromate. Let me give you one more example of the 4-membered families. IO minus, IO2 minus, IO3 minus, and IO4 minus. And you probably should be able to do these ones by now. This would be hypoiodite. This will be iodite. This will be iodate. And this will be periodate.